Hello, I'm Bruce Shane, and today we're going to take a look at bimetallic strips. Now, it's actually a fairly simple piece, but it has a lot of applications. They control the temperature inside a water heater, or in your house, there's a thermostat, which has a coiled bimetallic strip. That little dial on the toaster determines how long the bread stays down for. I think that was a little bit too long. They can make lights blink on and off, and even some clocks have bimetallic strips to keep them more accurate. Now, this is a demonstration bimetallic strip, so let's see how it operates, and then I want to show you how you can make your own version of it and demonstrate it yourself. Now, this piece is made of two metals. It has brass on one side and iron on the other side, and they've been pressed together. It's not a spring. If I bend it, it stays bent. But let me straighten it out here. Now, let's go see what happens when we heat it. You'll notice as I'm heating the bar, it's starting to curve. Now, why would it do this? Well, brass expands more than the iron does. So when the bar is heated, it expands unevenly with the brass on the outside and the iron on the inside. Let's see what happens when we cool the bar. By adding a little water, it's going to cool the bar back to room temperature, and notice that it's straightening itself out. If we were to freeze this, it would actually bend in the opposite direction. Now it's time to try our own version of it. In this case, I call it a bimaterial strip. These strips have aluminum on the outside and heavy stock paper on the other side, but it behaves the same way. If I heat this, the aluminum will expand and curve with the paper on the inside. Now, as you can see, by heating it, we get a pretty nice curve to it. And if we let this sit, eventually that metal is going to contract and cause this to straighten out. So let's take this to the table. I'll speed the camera up here so we see the results a little bit faster. Now, that took about 2 minutes for it to straighten itself out. We could peel it off and try it again. And of course, we're going to get the same results. The aluminum is going to cause the strip to expand unevenly, just like the bimetallic strip made of the brass and the iron. Let's go see how to make these. Our first method is going to use aluminum tape and a piece of heavy stock paper. I'm simply going to rip off a piece that's slightly longer than the paper is, pull off the backing. I'm going to pull it tight to get any creases out and try and apply it to the paper as smoothly as possible. There we go. Next, I'll use scissors to cut out the strip to the desired width and length that I want. There we go. And there's my bimaterial strip. Another version is to use mailing labels and simply attach them to aluminum foil. Once again, I'll put them on here and then I could cut them out. Another possibility is to use heavy stock paper, and I can smear some white glue onto the one side of it. There we go. Spread it out nice and smooth so I have a film covering the whole piece. And once again, now I'm going to take this and simply press it down onto aluminum foil, and that's going to take a while for it to dry. I made a few other ones earlier. Now all I have to do is simply cut them out. Now let's give these a try and see if they work. We'll start with the label that's attached to aluminum foil. Heat that up, we can see it bending. That's good. And this is the one that was glued. And there we go, we can see this one bending also. Now let's see if we can use these and apply them to a practical purpose. Now at the beginning of this video we saw these lights that are blinking on and off. They're actually being controlled by these bimaterial strips. How do they operate? Well, let's see. This experiment is going to start with a 6-volt power source and a 6-volt light bulb. Now the wires from the power source, well, one's going to go to this little red post here, and the second one's going to be wired inside that clothespin. You can see it a little bit closer there. Now the idea is if I run a wire from inside the clothespin over to that post, it completes the circuit and the light bulb lights. If I replace that wire with one of the strips and make contacts on both sides, the light bulb lights, and if I lift it up and break the contact, it goes out. So we're going to use this to turn the light bulb on and off. Now to make it a little bit more efficient, I'm going to color the aluminum side with a little bit of black marker, and that's going to help it turn the radiant energy into thermal energy, and that's going to make it work a little bit better. So I'll color it in here, put it back in. There we go. There are several factors that determine how quickly this blinks on and off, but I find once it gets into a rhythm, it's usually going to take about 20 or 30 seconds to make that change. I've built a few different versions of this piece, so let's switch over from a 6-volt system to a 12-volt system. Put this one away, and I'll grab this one. Here it is. Now the only real difference between this piece and the last one is that this uses a 12-volt bulb, which I got from an auto supply store. It's the heat from the light bulb that causes the bimaterial strip to bend up slightly, break contact, and the light bulb goes off. As it cools, the strip comes down and makes contact again and turns the light bulb back on. This is the same basic concept that bimetallic strips are used to control the temperature in all sorts of heating devices.